Welcome to Staffworks Explained. If you are here for the first time, please consider subscribing to this channel. In this video, we'll be talking about Julius Nyerere Hydropower Plant, which is set for commissioning this week or late August 2026. We say it's the long road from an old idea to a working powerhouse. Today, the story is not simply about a dam that has finally produced electricity. It is about a project conceived generations ago, repeatedly studied, abandoned, revived, politically accelerated, technically challenged, environmentally contested, and eventually developed at a scale capable of reshaping Tanzania's electricity system. The Julius Nyerere Hydropower Project, which was formerly known as Stiegler's Gorge, tells two stories at once. The story of a major infrastructure success, as well as a story of what happens when ambition, public finance, environmental risk, contractor or contract management, and grid readiness do not always move at the same speed. And there is an important clarification at the onset. The project was not completed years before it was commissioned. Construction and commissioning overlapped. The first generating unit entered service in February 2024. All 9 units have been commissioned and synchronized to the national grid by 28 March 2025. What has taken longer is the transition from physical completion to the formal ceremonial inauguration. As of 2026, government and Egyptian contractors were still discussing arrangements for the official opening. That decision matters because in project management, completion, commissioning, commercial operations as well as inaugurations are 4 different milestones. A plant can be mechanically complete but still undergoing testing. It can be generating electricity while final contractual works remain, and the government can hold a formal opening long after the asset is already serving the customers. The Julius Nyerere project has passed most of these milestones. The most interesting questions now is whether Tanzania has extracted the full value from the investment. Let's look from the Nyerere Hydropower Project development vision to a 2,115 megawatts plant. The idea behind the project is much older than the current dam. Planning around Rufiji Basin dates back to the early post-independence period. Studies in the 1960s and 1970s examines Stiegler's Gorge as part of a much broader development concept involving electricity, irrigation, industrialization, and management of the Rufiji system. Norwegian development assistance later supported detailed feasibility and engineering work, including studies by No Consort and Hafsland, but the project never moved into construction. Tanzania's economic difficulties, doubts over economic viability, and environmental concerns all contributed to its long dormancy. The project returns to the center of the national policy under President John Magufuli after 2015. The important policy change was not merely that Tanzania wanted a dam. It was that the government decided it would build and finance it itself, rather than wait for a conventional international financier or private developer. That was a decisive change in the project risk structure. In 2018, Tanzania awarded the main engineering, procurement, and construction and commissioning contract to the Egyptian joint venture of Arab contractors and Elsewedy Electric. TANESCO was the employer, while the TANROADS Engineering Consulting Unit acted as the supervising consultant employer's representative. The contract was signed in December 2018 and construction officially started on 15th June 2019. The contract value was Tanzania shillings 6.5 or 6.6 trillion Tanzania shillings, commonly reported as $2.9 billion at the time. Most importantly, the project was funded by the government of Tanzania rather than through a World Bank, African Development Bank, or other multilateral project financing package. That decision gave Tanzania control over a strategically important project, but it also placed the financing risk squarely on the public balance sheet. There's an important distinction here. Reports have referred to financing arrangement obtained by members of the Egyptian consortium, but those who should not be confused with Tanzania government project financing. The contractual obligation remained fundamentally a government-funded investment. What Tanzania actually bought from this contract? This is where the scale of Julius Nyerere Hydropower Project becomes clearer. The plant has 9 Francis turbine-generator units, each rated at 235 megawatts, giving total installed capacity of 2,115 megawatts. Its planned annual energy production is approximately 6,307 gigawatts per hour. The distinction between megawatts and gigawatts per hour is significant. Megawatts describe the maximum rate at which the plant can produce electricity. Gigawatt hours describe how much electricity can actually produce over time. But the power station is only one component of the project. The civil works include the main roller compacted concrete dam RCC, saddle dams, cofferdams, which are used temporarily to divert and control the river during the construction, diversion tunnels, spillways, the intake and water passages to the turbines, a powerhouse, roads, bridges, workers' facilities, as well as electrical connection infrastructure. The project is also incorporating 400 kV connection to move the electricity into the national system, that is evacuate the electricity to the national system. In other words, Julius Nyerere Hydropower Project was never simply a turbine installation exercise. It was a large civil engineering project wrapped around a power station. Let's now look at the schedule where the project lost time. Original schedule was extremely aggressive. The contract called for completion in roughly 42 months, including 6 months of mobilization. The contractual completion date was 14th June 2022. Tanzania's Controller and Auditor General later described the original duration as unrealistic given the scale and complexity of the work. Construction therefore continued well beyond the original date. The audit trail is revealing. By October 2021, overall implementation was reported at about 77.15%, while the project was still working towards completion. By December 2024, the National Audit Office recorded physical progress of approximately 99.35%, yet there was still no clear agreed completion date at the time of its audit. The completion target had subsequently been extended to May 2025. This is a classic large project lesson. A high percentage of physical completion does not necessarily mean that the project is ready for handover. The last few percent can contain testing, commissioning, defects, electrical integration, documentation, safety and certification, as well as interface works that are disproportionately difficult. And Julius Nyerere was dealing with exactly that problem. Now, where the contractor management became expensive. The most serious criticism of the project is not that it was delayed. Large hydropower projects frequently experience delays. The more consequential issue is why delays translated into additional public cost. Tanzania's National Audit Office found weakness in the original contract relating to price adjustment. The contract did not adequately specify how price adjustment would be handled if the project extended beyond the original completion date. When the issue went before the Dispute Adjudication Board, the contractor succeeded on price adjustment claims. For the 2023-2024 audit, the contractor had claimed about 1.14 trillion Tanzania shillings in price adjustment. The subsequent 2024-2025 audit went further. It identified 13 disputes, with Dispute Adjudication Board issuing 11 decisions, 8 of which were in favor of the contractor. The audit reported that TANESCO paid the contractor approximately $400 million US, which is equivalent to 889.6 billion Tanzania shillings, taking the revised EPC project to an about 7.144 trillion Tanzania shillings. The Auditor General attributed the claims to several factors, including price adjustment, contract management, weaknesses, and failures by TANESCO to fulfill certain contractual obligations. This changes the way the project headline price should be discussed. The often repeated figure of 2.9 billion US or Tanzania shillings 6.56 trillion is the original contract value. It should not automatically be presented as the project's final economic cost. From a project management perspective, this is perhaps the clearest failure in the delivery model. The government succeeded in getting enormous and technically complex asset built, but contract preparations and risk allocation were not sufficiently robust to protect the public employer from the consequence of delay and disputes. The Auditor General recommendation is therefore important. Future mega projects require stronger tender preparations, more rigorous treatment of high-risk contractual provisions, better negotiations, and specialist external expertise during complex disputes. And now another question, was the scope changed? There is evidence of scope management problems, but they should not be confused with fundamental redesign of the power station. The core power plant that was delivered remains the same basic proposition, 9 235 megawatts turbines producing 2,115 megawatts, supported by the dam, water conveyors system, powerhouse, and grid connection. However, audit records show that amended scope and as well as additional requirements were not always synchronized with the contractual documentation. One earlier audit, for example, identified a substantial delay in formally signing an amendment associated with amended scope, even though materials had already been delivered. The same audit also found materials supplied beyond original quantities without adequate documentary evidence supporting the additional requirements. This is not a trivial administrative matter. In a mega project, scope control is the mechanism that prevents a seemingly small technical instruction from becoming a cost claim later. The available audit evidence does not support the conclusion that Tanzania abandoned the original 2,115 megawatts concept and substantially redesigned the plant. The more defensible conclusion is that the project experienced scope administration, additional requirements, interface, and contractual changes within a broadly stable technical support. And now let's look at the environmental argument, which never disappeared. There's another part of the Julius Nyerere Hydropower Project story that cannot be responsibly left out. The dam is located within former Sealers Game Reserve, which is a UNESCO World Heritage property, whose name was later changed to Nyerere National Park in the Tanzania conservation system. UNESCO and IUCN raised serious objections to the project. The concerns were not simply about losing trees and a reservoir. They included the effect of regulating the Rufiji River, changes to downstream ecosystems, impacts on fisheries and livelihoods, wildlife habitat, and integrity of the World Heritage Site. As independent technical review commissioned by IUCN was particularly critical of the environmental assessment process. It concluded that the strategic assessment was inadequate and that important questions concerning economic viability, alternatives, and cumulative environment and social effects had not been sufficiently addressed. UNESCO noted that the strategic assessment was completed after the construction contract had already been signed and construction had begun. That is a major project governance weakness. An environmental assessment is most useful before the irreversible decision is made. Once the contract is signed, workers mobilized, roads built, and river diverted, environmental assessment becomes much less capable of changing the fundamental project decision. UNESCO remained concerned even after the plant became operational. In its 2025 decision, the World Heritage Committee noted that all 9 turbines have been activated and expressed concern about the project's irreversible impact on the property's outstanding universal value. The government counter-argument has been that the dam provides much-needed electricity, flood control, regulated water flows, and that the benefits are national in scale. That argument has considerable weight from an energy security perspective, but it does not erase the environmental cost. Both propositions can be true. Julius Nyerere Hydropower Project can be extraordinary infrastructure achievement and still impose serious ecological consequences. Now let's look at the operational test. Is the plant actually delivering 2,115 megawatts? This is where the story becomes more interesting. By March 2025, Tanzania had connected all the 9 turbines to the national grid. The government reported that national installed capacity has risen to about 4,031.7 megawatts, with Julius Nyerere Hydropower Project contributing 2,115. But installed capacity is not the same thing as electricity annually available at every moment. Tanzania's system maximum demand was 1,873.3 megawatts at the end of 2025, according to TANESCO. By February 2026, peak demand had reached about 2,199 megawatts, and EWURA reported demand of approximately 2,506 megawatts on average from July to December 2025-2026 year, depending on the measurement period used. That means the 2,115 megawatts from Julius Nyerere Hydropower Project is huge relatively to today's demand, but Tanzania demand is growing rapidly. It also means that the country problems have moved. Before Julius Nyerere Hydropower Project, the argument was largely, where will Tanzania get enough generation? After Julius Nyerere Hydropower Project, the questions increasingly becomes, can Tanzania evacuate, transmit, distribute, and economically use all the electricity it can generate? That distinction is now visible in the operating data. As of 2026, a report by the Citizen, citing discussions involving the Controller and Auditor General as well as the energy sector stakeholders, reported that Julius Nyerere was operating at only about 40% of the installed capacity, with transmission bottlenecks identified as a major constraint. This is the project's most important post-construction challenge. A 2,115 megawatts generator is of limited value if the network cannot move its output to where demand exists. In power system terms, the dam solved a generation constraint, but parts of the system still face transmission and evacuation constraint. The government has consequently been investing in transmission infrastructure, including a 400 kV lines, substations, and other components, while additional evacuation infrastructure is being developed to move Julius Nyerere Hydropower Project electricity into the wider national system. Tanzania's energy authorities reported more than 8,300 kilometers of transmission lines by June 2025, alongside continued transmission and substation project. This is not an optional add-on. It is part of extracting the value of the original investment. Now let's look at water. Hydropower has another inconvenient characteristics. The fuel is water, and nobody controls the weather. Julius Nyerere Hydropower Project was designed around large reservoirs precisely to regulate river flows and provide a more dependable energy source than runoff river generation. But long-term output will still depend on hydrology, rainfall pattern, and reservoir management. This matters because Tanzania's historical hydropower project power problems have often appeared during drought periods. The country's electricity system has therefore been shifting towards a more diversified mix of hydropower, natural gas, solar, and other sources rather than relying on one technology. That is sensible. Julius Nyerere Hydropower Project should not be treated as a substitute for generation planning. It should be treated as the anchor of a broader system in which gas, solar, wind, geothermal, and regional interconnection provide complementary sources of power when hydrological conditions are unfavorable. There is also the less glamorous operational issues of maintaining a plant of this scale. 9 large turbine generator sets, high voltage switchgear, spillways, gates, transformers, and kilometers of associated infrastructure require a permanent program of preventive mechanism. The real test of the Julius Nyerere Hydropower Project will therefore not be whether all the 9 turbines can run simultaneously during an inaugural demonstration. It will be whether they remain available, safe, and economically productive 10, 20, or even 40 years from now. Now, another question. What has Julius Nyerere Hydropower Plant achieved? You can say quite a lot. First, it has fundamentally changed Tanzania's generation capacity. At 2,115 megawatts, the dam or the power plant is by far the country's largest generating facility. Second, it has reduced the system's dependence on emergency and expensive generation during periods when hydrology and gas availability permit strong hydro output. Third, it has given Tanzania substantially more headroom for industrial growth. A factory, mine, railway, data center, or urban economy cannot expand confidently if electricity supply is structurally constrained. Fourth, the project has demonstrated that Tanzania can execute infrastructure of a scale that would previously have not been considered would have been considered exceptionally difficult. And there is a wider economic effect. A major power station is not valuable simply because it produces electrons. Its value lies in what those electrons makes possible: manufacturing, irrigation, commercial activities, transport, electrification, urban expansion, as well as improved productivity. The government has also pointed to flood management and wider water management benefits as part of the project intended purpose. But also, failures matter too. The strongest analysis of Julius Nyerere Hydropower Project should resist both extremes. It is accurate to describe the project as a failure simply because it exceeded its original schedule and cost. It is equally, it's inaccurate to describe it as a failure from that perspective because there was an exceeding of original schedule and cost. And it's also inaccurate to describe the dam or the project as unqualified success because all 9 turbines are now operating. The project succeeded technically, but it experienced significant weaknesses in schedule realism, contract preparation, claims management, as well as environmental decision making. It delivered an enormous asset, but at a higher cost than the original contract figure. It increased generation capacity dramatically, but the national transmission system has struggled to absorb the full output. It provides renewable electricity, but it also has some environmental footprints which remain a matter of legitimate international concern. And while the plant has been generating electricity since 2024, Tanzania still needs additional generation because electricity demand is rising quickly. TANESCO has reported a system maximum demand of 1,875 megawatts at the end of 2025, and other figures in 2026 show that peak demand is moving beyond 2,000 megawatts. In other words, Julius Nyerere Hydropower Project has not ended Tanzania electricity challenge. It has moved the challenge to the next stage. What's the real legacy of the Julius Nyerere Hydropower plant? The final verdict on this project should therefore not be written at the dam well. It should be written in the electricity that reaches factories without interruption, in the cost of power to business, in the number of households connected, in industrial output, and also in the reliability of the grid, in the health of the Rufiji Basin, in how effectively the reservoir is managed, and in whether Tanzania maintains the turbines and transmission networks well enough to preserve the investment for generation. The project began as an idea associated with Tanzania development ambitions in the 1960s. It survived economic crisis, changes in development philosophy, decades of feasibility studies, and long periods of inactivity. It was revived as a national strategic project, awarded to an Egyptian joint venture in 2018, physically built in 2019, began generating electricity, and reached full 9-unit operation capacity in March 2025. That is an extraordinary journey. But the lesson from this project is not simply that Tanzania finally built the dam its earlier government had imagined. The deeper lesson is that mega projects is never finished when concrete is finished. The difficult work now is operational. Moving the electricity, managing the water, maintaining the machinery, paying for the investment, protecting the downstream economy as well as environment, as well as ensuring that huge capacity does not become stranded behind transmission constraint. The dam or the project has answered Tanzania's old question, which was, can we build a power station big enough to transform the electricity system? The next question is harder, which is, can Tanzania build and manage the rest of the power system well enough to make the 2,150 megawatts on the Rufiji River count every day? That, rather than ribbon cutting ceremony, will ultimately depend or determine whether Julius Nyerere Hydropower Project becomes merely Tanzania's biggest infrastructure project or one of the most consequential investment. That is the story of Julius Nyerere Hydropower Project. The sources of this content or the analysis above has drawn principally on TANESCO's generation records, also from Tanzania Controller and Auditor General Technical and Public Authority audits for the years 2023, 2024, 2025, as well as official Tanzania energy sector publication. There's also public project information from the Arab contractors and Elsewedy joint venture, and also there is UNESCO and IUCN assessment of the project environmental implication. So thank you for reaching this far. If you are here for the first time, please consider subscribing to this channel. You can also watch other videos that you have made on this dam as it was being constructed and up to where it was completed, and other projects in Tanzania, the wider East Africa, and the Africa in general. So thank you, and let's meet in the next one.